Okay, in this lesson, we're going to be talking about compositions. And we remember compositions whenever we were talking about functions like f of g or g of f, and we're talking about the same compositions here. Recall, given functions f and its inverse, f inverse, if x is in the domain of both functions, then f of f inverse of x will always equal x if they're inverses. The way that we wrote it is f of g will always equal x and g of f will always equal x if the functions are inverses. And we also know that f inverse of f of x, if you compose the two, again, you're going to get x if they are truly inverses of each other. Okay, now, so when we're talking about trigonometric functions, we've got to be a little bit careful because this will only work if we're within the parameters where we restricted our domain and range. So if we're plugging in x here, we're finding the inverse sine of x, and then we're going to find the sine of that answer. That's only going to work if x is between -1 and +1. And the same thing with inverse cosine, where these two functions, again, are inverses of each other, but we're only going to get the x value back if, again, we're within the restricted domain. Same thing, the tangent of the inverse tangent of x. Those two functions will only cancel each other out if we're within that restricted domain. Now, for tangent, we were between negative and positive infinity there. So we can plug any value in between the two. So now let's do the other side. The inverse sine of the sine of x. Okay, which angles, because we're finding the sine of x first, which angles can we plug in to where this is going to work? So this only works for that restricted domain range. So the angles that we restricted sine to was all the angles between -90 degrees and +90 degrees, or negative pi over 2 and positive pi over 2. For the inverse cosine of the cosine of x to equal x, we would have to be between 0 and 180 degrees. Again, that was that restricted domain. And the restricted domain for tangent was -90 to +90, but not including those two, or negative pi over 2 to positive pi over 2. So find the exact values of each of these expressions. So if we find the inverse sine of -1/3 and then the sine of that, will these two functions cross each other out when we compose them and give us -1/3? Well, it only will if we're within this restricted domain of inverse sine from -1 to +1. So yes, it will. And the same thing for cosine of the arc cosine. Does it give me 2/5? Yes, it does, because 2/5 is on that restricted domain. Same thing with the third one here. The tangent of the inverse tangent of -9/2, and that will always cancel each other out as long as you're between negative and positive infinity actually there. So same thing here, we're going to equal 1/4. Okay, so let's work some problems. It says find the exact values of each expression if it exists. So keep in mind, as long as we're within the restricted domain and range, let me circle that. As long as we're within the restricted domain and range, a function and its inverse will undo each other. That's kind of like taking 1, adding 2 to it, and then subtracting 2. These two functions undo each other, and we get back to where we started. So the sine and the inverse sine, when you compose those two functions, and you have that example right here, as long as that x value is between -1 and +1, then those two functions are simply going to cross each other out. And same thing here, the cosine of the arc cosine, since 2/5 is within that restricted domain, then we are fine. There is an issue with the third one, the cosine of the inverse cosine of 3/2. Okay, it is this example. However, that x value that we're plugging in needs to be within this restricted domain, and the main reason for that is you can't even find the inverse cosine of 3/2. The inverse cosine of 3/2, well, cosine is only between -1 and +1, so this does not exist. The tangent of the inverse tangent, As long as we're between negative and positive infinity, we're going to get that exact same value back. So the exact same thing here. The sine of the arc sine. Now, again, I have a problem with this. Let's go back up here. This is an example here. The sine of the arc sine of x is equal to x as long as you're plugging in values between -1 and +1. -7/6 is not between -1 and +1, so we're not going to get the same thing back. Now, the inverse sine of the sine of pi over 4. Now, if you would like to, you could actually go through the process and find the sine of pi over 4, and then find the inverse sine of that. And here's what you would get. Let me go ahead and do it the long way. The sine of pi over 4 is root 2 over 2. So we're going to do the inverse sine or the arc sine of root 2 over 2, and we get pi over 4. You get the exact same answer back. So these two functions crossed each other out. They undid each other because, once again, pi over 4 is between -90 and +90. So we're fine there. Let's do one more here. The inverse cosine of the cosine of 5 pi over 6. The inverse cosine of the cosine. So that would be an example like this. It's going to equal x as long as x is between 0 and 180. 5 pi over 6 is definitely between 0 and 180, so our final answer, 5 pi over 6. They undo each other. Number 9, the inverse tangent of the tangent. As long as we're between -90 and +90, we're fine. And you can see that here. But there is an issue with this. It's non-inclusive. You do not include -90. So therefore, the arctangent of the tangent of -90, the tangent of -90 is actually undefined. You cannot find the tangent of -90. So therefore, this is no solution here. And then finally, the inverse sine of the sine of -pi over 3. Again, we have to remember where inverse sine, what the domain and range is there. And as long as this, when we're dealing with sine, as long as this is between -90 and +90, these two values will undo each other. So we do get -pi over 3 there. Okay, number 11, we have something different. What if the angle is outside of the domain? And you can read this note over here, but I like just working it out anyway. These two functions, the inverse sine and the sine, do not cross each other out anymore. You're not going to get 3 pi over 4 because, again, when we're dealing with sine and inverse sine, our restricted domain is going to be between -90 and +90. If you were to actually do 3 pi over 4, that's 135 degrees. That's outside of that range. So therefore, we've got to actually do this a little bit tougher or a little bit different. We're going to work this out. We're going to do the inverse sine of the sine of 135 is root 2 over 2. There we go. Is that going to return back this exact same angle? No, it's not. When you're going to talk about the inverse sine is restricted to angles between -90 and +90. That's going to return a value of pi over 4, which is between that -90 and +90. That's 45 degrees. So therefore, these two functions didn't just cross each other out. It returned a value that had the same reference angle that was between that -90 and +90, which is where arc sine is defined. The inverse tangent of the tangent of pi. Again, inverse tangent, domain and range is restricted to values between -90 and +90, or negative pi over 2 and positive pi over 2. This is outside of that. So therefore, let's work this out. The inverse tangent of the tangent of pi. The tangent of 180, that's going to be 0. So when you do the inverse tangent of that, that's not going to return that same pi back. It's going to give an angle that's between that restricted domain, which was between -90 and +90, or negative pi over 2 and positive pi over 2, which is 0. 0 degrees or 0 radians. The inverse sine of the sine of 11 pi over 6. Again, inverse sine is restricted to the angles, let's see, between, again, -90 and +90, inclusive. So therefore, this is an angle of, let's say, that's 330 degrees. So that's definitely not going to return the same angle back. So we're going to do the inverse sine of the sine, and I like to change that to 330. It just makes more sense to me. 330, we're going to find our reference angle. Well, first off, let's determine if it's positive or negative. 330 is down here. All students take calculus, only cosine is positive, so this is going to be a negative angle. Mark it out, put its reference angle. The sine of 30 is a half. So we're going to do the inverse sine of a half, negative 1/2. That's going to be a fourth quadrant angle again, but it's going to return the fourth quadrant angle between negative 90 and positive 90. And that's going to be a negative 30 degrees, or negative pi over 6, which again is this exact same angle. However, it returns the angle between negative 90 and positive 90, which is not 330. Then number 14, doing the exact same thing. Cosine is defined between 0 and 180, or 0 and pi, and this is without or outside of that domain there. So we're going to do the arc cosine of the cosine of negative 4 pi over 3. That's negative pi over 3 is going to be 60, so that's going to be negative 240. That's going to be the inverse cosine of, okay, let me draw a unit circle quadrant here. Let's see, negative 240, that's going to be negative 90, 180, 240 will be somewhere up here. So therefore, the cosine of negative 240 is going to be a negative value because all students take calculus. The reference angle, we go 180 plus an additional 60 degrees, and the cosine of 60 is a half. So we have inverse cosine of negative 1/2. Again, inverse cosine is going to return an angle between 0 and 180. So when you do the inverse cosine of negative 1/2, it's going to, again, return the same second quadrant angle. However, it's going to return the value that's between 0 and 180, which is going to be 120 degrees, or that's going to be, let's see, pi over 3, that's 60, so 2 pi over 3. So either one of those answers are fine. Okay, next up, we're going to mix some functions. We're doing this for extra practice with our unit circle values. So if we're going to mix these values, we're just going to do what's inside of parentheses first. So we're going to do the inverse cosine of the sine of pi over 6. Pi over 6 is 30 degrees. That's a first quadrant angle, so the sine is going to be positive. The sine of 30 is a half. So now inverse cosine. Again, remember where inverse cosine is defined. That's from 0 to 180 degrees. So that's the answer we're going to be looking for. Since it's positive, that's going to be first quadrant. So now it's between 0 and 90. The cosine of a 60 degree angle is 1/2, or pi over 3 if you write it in radians. Number 16, the arc tangent or the inverse tangent of the cosine of 0. Start with the cosine of 0, and you now have the arc tangent of the cosine of 0 is 1. Arc tangent returns a value between negative 90 and positive 90. So we're going to be looking for a value in the first quadrant. That's where tangent is going to be positive. The tangent of what angle in the first quadrant is 1. That'd be a 45 degree angle, or pi over 4. Number 17, the inverse sine of the tangent of negative pi over 4. Okay, tangent of negative pi over 4. Negative pi over 4, that's negative 45 degrees. That's down here. The tangent in the fourth quadrant, all students take calculus. The tangent is going to be a negative value. Now we can use our reference angle, which is a 45 degree angle. The tangent of 45 is 1. So we are looking for the inverse sine of negative 1. Now we're asking ourselves, where is inverse sine defined? And that's between negative 90 and positive 90. That's the answer that we want. So we want an answer, let's erase that now. We want an answer somewhere between here and here. Where is sine equal to negative? That would be down here. So really we're looking for an answer between negative 90 and 0. Sine, if you remember unit circle values, your sine is your y value on the unit circle. This is where sine is equal to negative 1 on the unit circle. That'd be at negative 90 degrees, or negative pi over 2. Number 18, the arc sine of the cosine of 5 pi over 6. 5 pi over 6 is 150 degrees. 150 degrees is a second quadrant angle. So all students take calculus. Cosine will be negative. Use your reference angle then, which is 30 degrees. The sine or the cosine of 30 is root 3 over 2. Now we're looking for where is sine equal to negative root 3 over 2. Okay, when we're defining sine, it's different. We define sine between negative 90 and positive 90. Since here we're looking for an angle whose sine is negative, then we're looking for an angle between negative 90 and 0. So that's going to be, again, I like to use the reference angle. The sine of what angle is root 3 over 2? That would be the sine of a 60-degree angle. However, we're looking for the angle down here whose reference angle is 60 degrees, and that's going to be negative 60 degrees, or negative pi over 3. Number 19, the inverse cosine of the tangent of pi over 4. Again, pi over 4 is a 45-degree angle. The tangent of 45 is 1. So we're asking ourselves, where is inverse cosine equal to 1? Inverse cosine is defined between 0 and 180. So we're looking for the angle between 0 and 180 where our cosine is equal to 1. Think about your unit circle, and that's a 0-degree angle or a 0 radian angle. The inverse tangent of the sine of negative 90. Pi over 2 is 90 degrees. So the sine of negative 90, here's negative 90 right here. Your sine value is your y value on your unit circle, which is negative 1. So we're looking for where's my tangent equal to negative 1. So now let's talk about tangent. Tangent is defined from negative 90 up to positive 90. Since you're looking for a tangent that's equal to a negative, that's going to be an angle in the fourth quadrant. Again, I like to use reference angles first. Forget about the negative and ask yourself, well, the tangent of what is positive 1? The tangent of a 45-degree angle is positive 1. So therefore, the angle down here between negative 90 and positive 90, who has a tangent of negative 1, would be a negative 45 degrees. It has the same reference angle, which is negative pi over 4. Number 21. The inverse sine of 1/2. Okay, to find the inverse sine, now these are a little bit faster. The inverse sine of 1/2, you're saying the sine of what value is 1/2, and that has to be an angle between negative 90 and positive 90. So that would be a 30-degree angle. So now it's simple. We don't have to worry about where it's defined or anything. We took care of that in the first step. The cosine of 30 is root 3 over 2. Number 22, the arctan of 1. The inverse tangent of 1, the tangent of what angle is 1? That would be a 45-degree angle since it's a positive 1. And again, that answer needs to be between negative 90 and positive 90 since it's arctan. And the sine of 45 is root 2 over 2. Number 23, the sine of the inverse cosine of 0. So the the cosine of what angle is 0? Now this needs to be between 0 and 180 degrees. And that would mean that would be a 90-degree angle. The cosine of a 90-degree angle would be 0. So what is the sine of 90? 1. And number 24, the tangent of what angle is root 3? And again, that's going to be an angle between negative 90 and positive 90. Since it is a positive angle, that means this has to be between 0 and 90 in order to make tangent positive. And that would be a 60-degree angle, has a tangent of root 3. So we're finding the cosine of 60, which is simply 1/2. Okay, next up, non-unit circle values. Here's what we're going to do. Let the inside equal theta, because the inverse cosine is the cosine of what angle equals 8 over 17. This answer that I've circled here will be an angle, so we're going to let that be theta. Determine which quadrant theta must lie in. Draw a right triangle and find the missing side, and then evaluate the outside. Keep the quadrant in mind. So first off, the inverse cosine of 8 over 17 is what's inside. That's what our theta is going to be. Okay, so since the cosine of theta is 8 over 17, cosine is positive in quadrant, I'll put Q for quadrant 1 and quadrant 4. That's where cosine is positive. Now, inverse cosine. Remember what we said about inverse cosine. Inverse cosine is defined between 0 and 180, which is quadrant 1 and quadrant 2. So therefore, since this cosine has to be in quadrant 1 or 4 because it's positive, it's only defined in 1 or 2, so that means that this theta is in quadrant 1. So we're talking about a quadrant 1 angle. So we're finding the tangent of an angle in quadrant 1. Just keep that quadrant in mind. So next step, what you're going to do is draw yourself a little right triangle. Label this as your theta. And if this right here is true, if we let this be theta, that means the cosine of theta is equal to 8 over 17. Because that's what inverse cosine of 8 over 17 means, is what angle would have a cosine that's equal to that. So since cosine is 8 over 17, that's adjacent over hypotenuse. That means that's 8 and that's 17. Pythagorean theorem is going to tell us the third side. And that is a triple. That's an 8, 15, 17 right triangle. So now what we're going to do is just find the tangent of that theta. Tangent is opposite over adjacent. So therefore the tangent, or let's just write the answer. The tangent of that theta would be 15 over 8. Keep the quadrant in mind. Since we're in quadrant 1, will that be positive or negative? Tangent in quadrant 1 is positive, so that's our final answer. Let's work one more of these. Start on the inside. Let this be your theta. Theta is the arctangent or the inverse tangent of negative 12 fifths. So therefore, tangent is negative in quadrant 2 and quadrant 4. Inverse tangent is defined between negative 90 and positive 90, so that'd be quadrant 1 and quadrant 4. So therefore, since tangent, this angle has to be in either 2 or 4, and inverse tangent has to be in 1 or 4, so that means that our theta is in quadrant 4. So we have a quadrant 4 angle. We're finding the sine of a quadrant 4 angle. Remember that. So next step, we're going to draw a triangle here. Label your theta. And we know that the tangent of our angle is negative 12 fifths. That's opposite over adjacent. And honestly, you don't even have to worry about the negative. You can just label it as 12 and 5, and we're about to take care of the negative for it. This is a 5, 12, 13 triple. So therefore, now we are finding the sine of theta. The sine of theta is opposite over hypotenuse, which is 12 over 13. However, we are in quadrant 4. Since we're in quadrant 4, our sine value is, all students take calculus, our sine value would be negative, so our answer is negative 12/13.